Okay, so in this case we had a flux of 7. Namely, there are 7 lines of electric field coming out of our closed surface. But Gauss's law says that it's proportional to the enclosed charge. So in this case, we just had one charge in there. So if I add another charge in there, how does this work? Let's try a different color. Let's see if we can do blue. Let's say I add another positive charge right in the center. Okay, they're supposed to be on top of each other. In that case, that will also make electric field lines that are pointing radially outward. And those electric field lines will also poke through the surface. Okay, so here they come. And now what's the total flux? Well, the flux from the green was 7. The flux from the blue is also 7, right? 1, 2, oh, we forgot this one. 1, 2, 3, 4, 5, 6, 7. And so the total now is, of course, 14. Now again, this is just a number. There's no units ascribed to this right now. And in some sense, it doesn't really mean much physically because we are just talking about a graphical picture of this electric field. More charge in there means more electric field lines coming out, means more flux through the closed surface of our Gauss's law. Okay, what happens now if we change that positive charge, the blue one, to a negative charge? Let's take a look at that. So let's change this positive charge right there to a negative charge. So instead of another proton, maybe now it's an electron. And we still have our positive one sitting right there. How would this picture change? Well, if they're really right on top of each other, the only thing that's going to change is the arrowheads. Right? A negative charge has electric field lines coming towards it, not going out. So let's change all the arrowheads to the other direction. Okay, now all those field lines are going to be pointing in. Here they come into the surface. And now what do we say about the total flux? Well, flux is how many lines are going through the surface, but there's a direction to it. The greens are positive because they're going out of the surface, but the blues are now negative because they're coming into the surface. And so what's the total flux in this case? It's 0. 7 minus 7. Okay, but is that consistent with this? Flux is proportional to the enclosed charge. If there's 0 flux, that means there must be 0 enclosed charge, and that is in fact the case. We have a positive, but we have a negative. So the enclosed charge is in fact 0, and in some sense it doesn't really make sense to draw any of these electric field lines because there would be no charge there. If the proton and the electron were really right on top of each other, there would be 0 electric field around it. Okay, so this is sort of a brief introduction to Gauss's law. And next lecture we're going to look at understanding this mathematically. Cheers.